unless I say to my wife to send you the file.
Yes, that's fine.
On your computer.
Yes.
It's the easiest.
Yes, okay. Can everyone hear me? Excellent. Well, this is the first time we've had a workshop in this theatre, though some of us have been to this theatre for theatrical performances in the past. It's very nice to be back here. I think it's actually a little bit more luxurious than the usual lecture theatre. It's nice to be up here on the stage. I can see you all very clearly. Thank you very much for coming. This is the 15th of a series of workshops, and it's really great that there's been nearly 20 years, more than 20 years actually, of these workshops. So what's so special about this particular one? Well, as everybody knows, my philosophy is to have a self-contained conference all in one building, where there are meals, there are presentations, we can sleep, and we can have more social interactions. And the social interactions actually are just as important as the formal presentations. We don't disperse people to their hotels in the evening or to other restaurants for lunch and dinner, because this is really wastes a lot of time, and it limits the coordination between the various participants. In order to lubricate the social interactions, there's an open bar every evening, except on Wednesday when it's the gala dinner, at between 8:30 and 10 o'clock. So that's a good incentive to arrive early for dinner, because you'll be missing out on valuable drinking time, free of charge, in the hotel bar. The meals are in the basement restaurant, which from now on will be the Ristorante Il Rosetto, where we ate for breakfast this morning. The gala dinner will be somewhere else. That will be in the Sala Perfetta Letizia, but as it's a one-off, I'm sure everyone will find it very easily. It's on the ground floor. People were supposed to have come to collect their badge this morning in the office, but I think only one person did. Thank you, Iwamura. You can also pick up some pens. There are some books which we're giving away free of charge. You can print your paper because there's a printer there. And don't forget to wear your badge, because you will need it to get to the open bar in the evenings. Also, it's helpful for everybody to know who you are, so they can address you and make quite sure there's no problem. As I say, there's 28 years of workshops, though I have to confess the first two in November 93 and 95 were organized by Fiat, not by myself, but I've organized all the other ones from 1997 onwards. So this is my 13th, and I hope not too unlucky a workshop. Everything seems to be going pretty smoothly so far, though I'd say it myself. And after a 3-year gap, there will be the award of the Giuliano Preparata Medal. ICMNS has very recently minted quite a few of these medals. The new medals actually look better than the old ones. They're a little bit thicker and heavier, and I think they make quite a good award. We'll discover who is going to get this award at the gala dinner. I've written here 50 participants, but we're actually 57 if we calculate all the wives and girlfriends who've attended. I should say that if you have a badge, you're entitled to all the facilities of the workshop. That means coffee breaks, meals, and so on. There's no discrimination whether you're actively participating or not. So this is quite a good turnout, I think, for 2022, because last year we managed to get about 30 people only, but of course COVID was inhibiting a lot of international travel and indeed national travel. This year there are no particular rules for COVID. There's no distancing rules. You don't have to wear masks, even if the staff wear masks. And we should do a little bit better than breaking even because of the higher numbers. The conference includes all meals for residents. That means breakfast, coffee breaks, lunch and dinner. I think I've covered the rest of that. Lunch is at 1 o'clock. Dinner is always at 7:30. When the workshop's over, you can submit your paper to Jean-Paul Biberian, who's the editor-in-chief of the electronic journal. If you also have taken some digital photographs, I'd be very interested in having copies, and I can put them on the website with your permission. Or even if you don't give me your permission, I'd like them anyway as for a personal memento. I don't have time to take photographs myself. Publication will only be electronic, so no printed copies. It makes things a lot cheaper that way. PowerPoint presentations are all 30 minutes, including about 5 minutes for question time, and moderators will be enforcing those limits, though in exceptional circumstances, if a long coffee break is coming up, which is 30 minutes long, we might be able to allow some minor overruns. People have asked me about the program, and unusually, rather than printing programs and giving them to people and then discovering the program changes, which causes a lot of confusion, a program will always be appended outside the theatre, as you've probably noticed as you came in. In addition, the moderators will have a copy on the desk here. And in addition, you can download the updated program. Actually, it hasn't been updated significantly, on your telephone over the internet at the address shown here. The program does change due to presenters arriving late. I think there may still be some people who have not yet arrived. Certainly there are quite a few badges on my table in the Sala Sapienza, which is my office. Due to a cancellation, there's one free presentation slot, so if someone's got an extra paper to present, that's possible. Alternatively, instead of a paper, we might want to have a discussion, and I think the Clean Metal Hydrogen Energy Consortium didn't have time to talk about the next ICCF, so that could be a topic of conversation. I mentioned the free publications in the Sala Sapienza. I think some of these have already been sold out. They're all free though now. In the past I used to charge for them, but I've still got quite a few boxes at home and I'd like to get rid of them. Those of you who need a certificate of attendance can just ask for one. This is a rather old one from a couple of years ago, to a Russian, and of course there are no Russians present due to the Ukrainian situation. If you need help, you can ask at the conference reception that is in my office, or you can ask an old-timer, or you can read the notice board. People don't tend to do that. And the workshop program may well be updated in the future, but it certainly hasn't changed significantly over the last 48 hours, which is great. I think people are learning that a little bit of discipline in sorting out their presentation times is greatly appreciated by the organization. If you've got a car, you can park in the front car park, and you can use your room badge to open the barrier. If you don't have a room badge, you can just use the intercom and just say your name, and they'll almost certainly open it anyway. Getting back home after the workshop, the train is the fastest way to get to Fiumicino Airport, and you can look up on the internet trainitalia.it, and it'll tell you the prices. You can book your tickets online, paying with a credit card. Failing that, you could ask any member of staff. That means me, I suppose. We might be able to organize a taxi if you don't like the train, and you could share the cost of getting to Fiumicino. It takes a little bit longer, actually, but probably is a lot less convenient, less stressful to drive than take the train if you don't speak Italian and so on. Remember to leave your room at 10 o'clock in the morning, and if you've still got baggage there, you can ask the hotel staff to put it in a deposit room. Make sure that all your personal debts are settled, because obviously drinks from your room fridge are not included in the conference, but for almost everything else is. If you've got any suggestions to make this workshop better, comments, suggestions, complaints, they're all gratefully received. We want to improve. And you could speak up privately or publicly in the closing discussion on Wednesday, or you can just email. It doesn't matter what the source is, we'll take your comments into account for future meetings. I need to say a word about thanking sponsors. I think only some of them are actually on this slide, because sponsors have come in I think there are 10 sponsors now, actually. But you can see a full list of names on the Book of Abstracts, which is online, on the workshop poster. They're all there. And I want to thank Alberto Carpentieri, who is my co-chairman, and Claudio Pacci, who's been a chairman in previous years, but has now demoted himself to just being on the local organizing committee. He's responsible for such things as the excursion, the entertainment at the gala dinner, and so on. And Asya, is she here somewhere? Hello. You're meant to be helping by... well, you know what to do. And of course, we mustn't forget Sabrina, who is on the hotel staff, and she has been incredibly patient and helpful. And I think without the support of the hotel, really, we wouldn't get anywhere. So one of the reasons we come back here, because we've established a very good relationship of trust. They don't make me pay until everyone's gone home and this kind of thing. It's a few thousand euros the cost of a conference. I would remind you, there's no smoking anywhere indoors in Italy these days, anywhere public. Obviously, in the private of your own home you could. So I would ask you to just go outside the entrance if you need to smoke. I always like to suggest default questions for presenters. And so I'm going to read them out because I feel personally, but this is purely a personal opinion, that they're rather important. So to experimentalists, I would say, do your experimental results support or invalidate any theoretical model? Because that's what experiment should be about. A major objective of experiment is to test models. It's not to demonstrate that cold fusion exists. We did that 30 years ago. Really, we have to move on now. And to theoreticians, I say, are your theoretical predictions consistent with experimental results? Somehow, people overlook this rather elementary check. Is the theory falsifiable? And if it's not falsifiable, why are you presenting it? Because it's not scientific if it's not falsifiable. So we need to be a little bit more critical, and I hope all the presenters will attempt, at least, to answer some of these rather basic questions. Also, at the end of the workshop, there'll be time for a discussion on the last day. That's to say, on Wednesday before lunch. What kind of experiments should we now be doing, and why? Is there any point in doing purely calorimetry uncorrelated with nuclear measurements? How can we identify the processes underlying condensed matter nuclear science? 33 years have gone by, and we still do not know what the basic reactions are. It's all speculation, not backed up by experimental evidence. And fourthly, how can different groups collaborate? And I think Konrad Czerski has demonstrated with the Clean Metal Hydrogen Energy Consortium that international collaboration is possible and productive, and it's a great saving of cash not to duplicate other people's work. So I think this ought to be the way forward, and maybe this is another topic we can discuss at the end of the conference, because sooner or later there will be more calls for European Union projects, and maybe people who didn't join last time can join in the future. And now I have some personal questions for you myself. How many of you went to ICCF 24? Can you raise a hand, please? Oh, quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's quite a good number. And I think that indicates that people see some value in these workshops in Europe when there's an ICCF, even only 2 months ago, in another continent. The reason why I ask this question is I don't want to interfere with, I don't want to steal participants from an ICCF. I mean, we're here to collaborate after all, so a little bit of sensitivity, maybe I'm a bit overly sensitive, to take that into account. For example, next year, there should be an ICCF 25 in Poland, which means Europe. So a lot of people might say, well, we don't want to have a workshop in Europe as well, but that's something we can discuss on the last day. And there are some people, I guess, obviously, who did not go to ICCF 24, who've come here instead, and that's understandable if your financial resources are limited, because it's quite expensive to go to America and so on. So my guess is we will continue workshops, but possibly there won't be one next year. Okay, any questions? Yes.
All right, yeah. You mentioned the fact that we should correlate excess heat and nuclear reactions.
Yes.
I agree with you, but measuring nuclear ashes, whatever it is very difficult, and most laboratories are not equipped to do that. And the second thing is that what I want to do at this point is amplify the effect of excess heat. It's not to demonstrate that cold fusion exists, that we know it from 30 years ago, but to amplify it and to bring it to the market scale, you know. That's my point in doing my experiments, even though I like knowing what's happening inside the cell.
Okay, I don't quite agree with that, because if you haven't got the right equipment in your lab, get the right equipment. There's no point just measuring excess heat and randomly changing parameters, hoping you're going to increase the effect, maybe on the basis of previous observations, is also not going to be very productive. We've tried this for 30 years, and it's failed us.
And I would like to make a comment on this comment, you know, because even if you have something producing a lot of heat and you want to market it, if you explain to customers you don't know why it works, try to sell it.
I agree entirely. No authority is going to license an unknown nuclear process.
Okay, I agree that if we don't have a theory, it's not good. But we have to realize something similar happened in the developing of high-temperature superconductors They work very well for over 35 years, and still now there is no theory, no acceptable theory. If you study deeply the superconductivity, you have to have idea that what we see is impossible, it's fantasy, but the material work. So I think we don't have to worry too much about theory. If there is, okay, welcome, but no, it's no true limit.
But Francesco, if we had a theory of superconductivity, we might be able to get to room temperature conductivity.
Yes.
And that would be very helpful.
Yes, but
rather than the liquid nitrogen temperatures.
but it's the point. Even we don't have theory, now we use high temperature superconductor in the practical life. So we have to consider.
Yeah.
We don't have theory, but we use successfully every day.
I understand.
I agree that experiment is most important, in our field. But the question is, or maybe there is also experience of the last years. There are many experiments showing that there are some nuclear products also at room temperature experiments. So there is no contradiction between, theory and experiment. We should explain the experiment results using a special theory for that.
Well, we don't have the theory which explains the experimental results. That's the trouble.
Yeah.
And some of those experimental results may be exaggerated or incorrect because they're often one-offs. They have not been replicated extensively.
Yeah, there are. Okay, we can discuss during the conference, the workshop. There is very important subject, I would say. If you want to say something, we should have this correlation between heat excess and nuclear products. Yeah, and then we should be sure about it that there is no radiation emitted that can be danger. If you want to, license that, what you said, it's difficult to say. Yeah, we cannot measure something, and therefore there is nothing there. So we should be sure about it.
I think that we should also consider spatial arrangement of elements in the substrates that are used in experiments, because often element potential synthesis has been criticized on zone refinement or concentration or so forth. So if you're observing, say, excess heat or radio signatures or coherent light or something like that, and that is correlated with an increase in spatial arrangement of elements, potentially new elements, that should also be considered, and I rarely hear that discussed.
Oh, I've discussed it in the past.
And that's commendable.
Okay, next speaker, who is Jean-Luc, I think. Jean-Luc Paillet. Okay, Jean-Luc will speak about the physics beyond the standard model for Lena theory, a survey of string theory. lost the mouse.
Panier. Which sense is here? So.
Come up every time.
Yes, panier assis. Is it possible to only this? No comment. As a comment in mode presentation. Yes. Yes. Perfect. And comment ça marche ça? Ah, ok. I begin? Yes. I present to you a little survey of string theory as I present to you a little survey of string theory as possible framework beyond standard model to progress theoretical research on cold fusion. The ambition of scientists is to deduce various physical phenomena from a few fundamental laws. The standard model is a current theory describing the four fundamental forces in the universe: electromagnetic, strong nuclear, weak nuclear, and gravitation. Electromagnetic is a historical identification obtained by Maxwell's theory and open door on special relativity. More recently, there is a unification of electromagnetism and weak nuclear, but there is still to unify gravitation with quantum theory, as general relativity is a classical theory. Represent elements of string theory which provides an unified description of four forces and much more hypothetical particles beyond standard model and implication in nuclear force and condensed matter theory. First, the primitive object, the strings and brains. Strings are tiny elementary objects supposed of order Planck length, vibrating at different frequencies like violin strings and interacting with each other. Transversal or longitudinal vibration give specific properties. Strings have standard physical parameters and lie in space-time with dimension often greater than 4. A string can be open with two endpoints or forming a closed curve. A brains is a new kind of dynamical extended object. D-brains are brains for open strings. Their endpoints have to lie on D-brains. They are fixed on D-brain is a Dirichlet condition, or free to slide on it is a Neumann condition. The space dimension of a D-brain is deduced from constraints due to properties of attached open strings. Likewise, the space dimension of a class of string can be deduced from constraints of this class. Dimensions can exceed 3, but the extra dimensions are compactified, wrap them very tightly in small compact space by periodic identifications of points of a fundamental domain. Imagine a circular winding for one dimension and a toroidal for two. Compactification can concern strings or brains and has a great role in real physical properties of strings. We can say physical questions are translated into geometrical properties. Lichen coordinates are very useful to relativistic representation. Here we illustrate a compactification on 2 dimensions with a single winding for each one. To be visible, the winding is not really compact on the slide. We end up with toroidal winding here. Transformation. The dynamic of relativistic string can be defined in Lagrangian mechanics. Equations of motion are obtained from stationary action along the path of moving objects. For a relativistic particle, it's very simple. The action must be proportional to traveled proper path. The history of particle is called world line. For a string, the path traces a 2D picture called a worldsheet. And string action has to be proportional to proper area of worldsheet. So we must define an area functional for spatial surfaces and choose a specific surface parameterization from some invariance properties. This leads to the Nambu-Goto action. We indicate the expression of action. With Lagrangian density L containing derivatives of string space-time coordinates. Motion equations involve densities of space-time momentum carried by the string. For it, we can show the moving of string is transversal. Dimensional analysis leads to interesting concepts of conserved currents and chairs. Finally, we can find a parameterization leading to a dramatic simplification of motion equation into a wave equation. With boundary condition and Layton coordinates, we obtain oscillator solutions in transverse Virasoro modes for x minus coordinate. Now, the quantization. We summarize the quantization process for open strings. Equations of move are wave equations. With Layton gauge and quantization similarly to the points particles, we can obtain commutation relation where position and momentum are conjugate operators. As the commutations are technically delicate to handle, we finally consider strings as harmonic oscillators. Then Virasoro modes become operators with commutator algebra. Theory must be Lorentz invariant and have quantum and consistency. So, creation and annihilation and number operators can be defined, like in quantum field theory. State space equals a Hilbert space called string field theory with interesting properties. Quantum consistency implies dimension is 26. Photon states appear naturally as massless states with polarization label. There are also strange particles with negative square mass called tachyons, indicating the de Bruijn support is unstable. Quantization of closed strings is similar to open ends, but the absence of endpoints leads to new features. The general solution of wave equation has two components, a left moving plus a right moving. So closed string operators combine two copies of open string operators, in fact. Most important, quantization of closed string provided new types of massless state associated with specific interaction. So gravity appears naturally, and graviton states have a spin too. A new tensor field, the Kalb-Raman field, arises as tensor generalization of Maxwell field A mu, the magnetic vector potential. With a corresponding strength tensor, a conserved current matrix, and a charge vector. This field could be maybe related to dark matter. A new scalar field, the dilaton, is associated with the string interaction forces. So far, only bosons appeared in string theory as force mediators. But we should also to meet fermions, like electron and quarks, etc. Then we need to introduce a bit an hypothesis beyond standard model, the supersymmetry. There are two classes of particles, fermions and bosons. And SUSY, suitability for supersymmetry, for each particle in one class, there is a partner in other class, having mass of the same order but spin differing by half integer. Motivation for SUSY comes from a big puzzle in standard model, the hierarchy problem. As strict SUSY leads to hypothetic particles of not credible masses, possibility will be on hidden SUSY breaking, giving very high masses not yet observed. With superstrings, we have commuting variables for bosonic string and anti-commuting for fermioning. The latter have two components, right moving and left moving. There is a two-first dichotomy due to boundary conditions giving two sectors, Raman sector and Nove-Schwarz sector. Space-time dimension of superstring theory is 10. As there are no notation, d branes are stable. Finally, a closed superstring combines two copies of open strings, giving further classification in types. Superstring make possible to represent all particles of standard model. The central principle is to build specific configurations of intersection of D6 branes in some type of superstring theory. In the 10 dimensions of theory, 4 are classic space-time and 6 are extra coordinates compacted with each dimension turned in a circle of same radius, giving finally a 6D torus. We consider open string. It can be read as product of 3 2D tori seen in projection and copies of the colored torus at the left. We consider open string stretching from one brane to the other, localized near the intersection of two D branes. With suitable conditions, the strings give rise to matter fields with features of fermions. Multiple intersection can provide the observed multiplicity in each generation of fermions. Standard model gauge groups determine correct configuration, and brane intersection break all supersymmetry. Gauge group of Yang-Mills theory can be realized with coincident D branes. We illustrate it with simple unitary groups U3. More precisely, several not coincident collections of coincident D branes can provide all particles of standard model by suitable intersection of the D brane. The details are cumbersome to develop as a lot of features must be analyzed, chirality, sign, or color of stars. We first consider massless fermions, and then they obtain their mass thanks to X field. Note the simplicity of the X mechanism. Here, a product with the field, the X field, and acquisition of mass, and obtain. And there is to consider the Yukawa coupling, the strength of the coupling. Is not completely Y is judge or judge force. Is still open problem in standard model. We can recall the X mechanism in electrowave symmetry breaking, and we indicate how to get it in the brane model here. By your recombination. Now, a natural question. Is it necessary to obtain fermions? Some authors try to do it without it. Now we look at interesting relation between nuclear force and strings. In fact, string theory began in the late 60s as theory of strong nuclear force, with size of strings supposed of order nuclear dimensions. But then it was abandoned for quantum chromodynamics. Here we can see a meson is a pair of quark and antiquark, bound by a thin tube of color field line. Tube could be interpreted as an open string. Indeed, if considering energy involved in the quark's confinement and comparing with energy to stretch the string, this interpretation is a good approximation. A correspondent exists too with a decay chain of hadronic excitation. The relation between quantum state for mass and angular momentum for hadrons is similar to the corresponding relation for rotating open strings. In fact, string theory gives a lot of information on nuclear interactions. But the most extraordinary is the anti-de Sitter conformal field theory correspondence proposed in 1997 by Juan Maldacena. Closed string propagate in the space whose boundary is approximatively the space where good theories lie. The duality is the highlight of the program. To make a simple, anti-de Sitter space is a space with constant negative scalar curvature. It's based on hyperbolic geometry like Lobachevsky geometry, Poincaré metric, etc. The figure at the top is a piece of a 2D anti-de Sitter space embedded in our 3D space. Below, we can see an hyperbolic disk or Poincaré disk. The tiling helps to visualize hyperbolic geometry. We can also imagine the disk as a projection of a sphere to visualize a curvature. Note the sides of the tiles are not straight lines but curves. Note the Dutch artist Escher is famous for its hyperbolic tilings of disks with various forms. Conformal theories are invariant for conformal symmetries, an extension of Poincare transformation with two essential properties: conservation of angles, possible scale exchange of metrics, but not conservation of distances. The illustration below the illustration shows a dramatic conformal transformation of Cartesian grid. Right lines are changed into curves, but the right angles at intersection of lines are conserved. It's clear the distances are totally disturbed. For gravitational physics, a system in a macroscopic region is said holographic if its physics can be represented totally by a theory living on the boundary of the region. Holography is derived from physics of black holes. The illustration gives a very simplified idea of duality. A QCD is not exactly a conformal theory, but conformal symmetry in QCD is studied in some works, indicated in the comment, and other works consider judge theory having no supersymmetry to apply directly to QCD. In fact, thanks to duality, one can solve by strings some problems on nuclear force integrated by QCD, and reciprocally some difficult questions on string using QFT reasoning. Here we emphasize the duality has further implications, especially on black holes, about entropy question and Hawkins paradox, and also on condensed matter and exotic states of matter, like superfluids. Note the cross-study of string theory and QFT contributed to new calculation methods allowing to overcome the combinatorial complexity of Feynman diagrams. In conclusion, we can say string theory is a huge and scalable fundamental framework. It's not exactly a theory that I only touched, but hoping I gave you the desire to explore more. Here are some references as on the poster and the comment of the slide. And finally, thanks for your attention.
We have 8 minutes for questions.
Thank you very much, Jean-Luc, for an interesting presentation. Bob Grenier, volunteer with the Martin Fleischmann Memorial Project. So I've got 2 questions. The first is, can you expand on what you mean by 6D tori?
Why it will be very complicated and long to explain why 6D. Yeah, because it's a mathematical computation which gives this constraint. Is a constraint is not arbitrary choice, but the result of computation about the property of strings, which lead to this.
Okay, thank you. The second one is, I'm very curious because you said something like that black holes may appear as fuzzballs and strings. We've created what potentially is ball lightning, but looks a bit like a black hole in that it completely disappears matter. But on the boundary interface on some copper, we have these holes, which are very well defined, 3.6 microns, and they're like all over the place, like it was a ball of strings. Can you expand on the ball of strings idea for a black hole?
Yes. In string theory, in string theory, we consider the black hole is more rich than in the general relativity of Einstein. In the theory of Einstein, there is, I think, only three parameters: the mass, the speed of rotation, if there is rotation, and the charge, electric charge. But with string theory, consider the black hole can contain a lot of strings inside, and this something is a joke to say hairy chevelu in French, hairy black hole, because there are a lot of parameters, additional parameters further. And the possibility gives the property, for example, about the entropy. The possibility to find the entropy and I have to be very summary because they are very, very complicated to explain. But with string define the relation with theory and information and the problem of Hawkins. So see the evaporation of some black hole make the information is lost. But with other parameter in the black hole theory, it's possible the information is at the boundary of the black hole, and but the hypothesis is not completely proven by mathematical proven because very complicated computation, and in this case it is possible to have a problem. There is a possibility to fire a wall, and which destroys the information. But there is a polemic about this question.
I have some very interesting scanning electron microscope images I would like you to consider, so when we can get a time together.
Yes, thank you.
No more questions?
So thank you, Jean-Luc. You say this theory is not a theory, but this is a theoretical framework, you know. And what is your next step?
Next step is continuing. In fact, is continually in progress, because some computation are rather holistic, and there is necessary to make, for example, the IDS CFT is there is in the I'll show you. For example, a very interesting yes, this Professor Matt, presentation of Martin Hammond. The date is miss 0 2002, not 202. Zero. Is a recent presentation with a lot of detail to almost prove more mathematically, more formally, the famous IDS CFT correspondence is very important to make relation with nuclear forces. And is other. I was very inspired by the school. Is easy to read. Easy to read. Yes, easy to read because is based on mathematics of first year in university. Differential equation, integration, etc. There's not some, for example, David Tung is more complex. David Tung is a very excellent course, but more difficult to read because introduce some geometrical science, and it's very important to use this. And that.
Okay, the next speaker is George Angeli, who is going to talk about the physics behind the Lena effects.
Yes, it's working now. Maybe you know, maybe you don't. The Pope was here in Assisi for 3 days the last weekend, and he met with the youth of the world, and he asked them to cooperate to save planet Earth, the collapse of the environment. I think he addressed the wrong people. He should be here. My personal opinion that only in this room we have the key to the solution. The problem is that our PR is next to nothing. I'm always wondering, and in private conversation, I would like really to have your opinion. How come that there are dozens of hot fusion startups and they get $10 million, sometimes $100 million, and they show nothing, only promise. We are much better in showing up things, and showing up things, and yet we don't have funding, practically nothing. So I don't know what to do. Maybe there are some wise people here, and you may come up with the idea.
Can you stand up here, please? Otherwise the video can't take you.
Okay. So my opinion is most probably completely different from your one, because everybody is looking here for the holy grail, the effect which makes cold fusion work. In my opinion, this is a very, very wide word. Lots of physical processes are involved, so there is no holy grail. There is no one big solution, but there are a host of phenomena depending what would you like to do. Maybe if you want transmutation, that's a different machine, different processes. If you want heat and nothing but heat, that's another technical setup with another technical engineering solution. If you want to get electricity, that's again a completely different physics and completely different engineering solutions. So most people are working on this area, and as we know, I don't want to explain further because in the last 30 years there are talks and talks and talks on this very area. I had experience, of course, on this area also with the Patterson device. I was disappointed with it. It's a large surface area. The problem is that we always have shoestring budget, and we didn't have access to the cleanest lithium carbonate, so our cathodes were always polluted after some hours. Some stain appeared on the cathode and it stopped the phenomena. So it's again a very unreliable process in my eyes. Also another unreliable area is cavitation bubbles underwater and sparks in the water. This is the easiest. The internet is full of these solutions, and they yield heat and transmutation. It is very cheap. very hard to repeat the same experiment again, very hard. So I had more than 10 years of hands-on experience with transmutations, with dusty resonant plasma, and in my opinion, all the stars and quasars are working on this principle, because the quasar is a runaway star. Just to show you the output of a quasar, it's a single object in the universe. It's more than 1 million galaxies, and they give away their power in about a year or two. So it cannot be explained on hot fusion, no way. And it is acknowledged that quasars cannot be explained on hot fusion. But then what? Then there is the usual stuff. Okay, then maybe black holes are doing. But the black hole is like Santa Claus. You can associate any properties with Santa Claus, and you can associate any properties with the black hole. It's not an explanation. It's just another box. But as I just briefly explained, dusty resonant plasma is relatively easy engineering project. I will show you some slides. And the advantage of it is that though it's very noisy, it is quite simple to implement. And my favorite idea is catalytic quasi-particles. That is, we call it condensed plasmoid, but the Russians used it explosive plasma, and the German radar, who actually maybe first time published about it in the 1930s, called it avalanche kind of discharge. We shall talk about it later, and Bob Grenier talks quite a lot and useful data about this area. And one of my intellectually favorite idea is biological transmutation. I know Bill hates it, but I know that it does exist, because mountains were built, limestone mountains were built during the millennium of years. In my opinion, biological transmutation, building calcium. And nature uses to build bones and shells of calcium, which is the easiest nucleus to assemble. So it is worth investigating biological transmutation. My heretic and personal opinion, there is much to learn from biology. The best engineering is in biology. The trouble is that it is so sophisticated, we don't understand. Why should we understand if we don't understand even more simple stuff? More simple stuff. So there is much to learn. I know that Bill won't let talk anybody on this subject on the next meeting, but I think at least in private we should start discussing it. Biology is very tricky. My opinion is that the current textbook physics is plainly not enough to understand biology. It is not even enough to understand cold fusion. My definitely sharp stance on this matter, that cold fusion is mystery because it cannot be described by textbook physics. And I found many instances where textbook physics are simply not describing nature. I shall talk about that. I wrote a long series of papers on the background of LENR in infinite energy. I won't have, of course, time here to explain it in details, but here you can find them. The most telltale experiment by Takaaki Matsumoto was, for me, the most revelatory experiment, and it was more or less classical Pons-Fleischmann kind of experiment, with one exception. He used thin palladium foil and used nuclear emulsions to look after byproducts. And that was revelatory because he found traces of the same stuff which Ken Shoulders discovered. Actually, these very unusual objects, condensed plasmoids. These are the usual Pons-Fleischmann device, and there are zillions of variations. You are familiar with it. And these are the Patterson cells which we built, and we had very, very good results for one day, and then after everything deteriorated. So my opinion that it is not useful for commercial use, because after a day or two it is just deteriorates. This is my first device on dust fusion, but here the dust fusion is just ordinary carbon coal, and here there is a resonant device, so this plasma is oscillating and rotating. It is visible here that it rotates, and due to the heat production of cold fusion, much less CO2 was produced, and I realized later that this process was discovered at first by a French oven builder who just by accident, he built fireplaces, and by accident he discovered when fireplaces are in the resonant mode and the whole building, the whole home is shaking, the flame becomes white hot and the CO2 disappears. The problem with it that it melted the doors, so lots of excess heat was produced and lots of noise. And we can talk about that later. All right. I'm trying to have the next slide. Yes, here. It's another angle. You see that everything is red hot, so we got lots of excess heat here. Where should I point this one? Oh, yes. This is the whole setup, the data acquisition here, input, output. The heat measurement is not shown because it is it's a heat exchanger on the tube. The tube is quartz tube, otherwise everything melts. Where should I point this bill? To the computer? I did it. Okay. Thank you. So, how can you expect repeatable LNR experiments when this pointer is not repeatable? Okay, this is, for example, a wind turbine which makes the pulses, pressure pulses, which make the whole combustion resonant. And the resonant plasma, the resonant dusty plasma makes the excess energy. Why? Because in these devices, in the dust fusion devices, all the dust particles are charged electrically, because the speed of the dust particles and the speed of the electrons and the speed of the ions in the plasma are always word apart. There are orders of magnitudes of difference. Electrons are very fast, accumulating on the dust particles, and they rotate. And this is my first point, that what is missing in physics. In electrodynamics, rotation is completely missing, and we know it. There is no magnetic monopoles, there are no magnetic currents. The zeros are there, but we don't know how to do it. It was discovered in the 1920s and 30s by Felix Ehrenhaft, a physicist in Vienna, who happened to be, unfortunately, Jew. So for this reason, the Germans, the Nazis, suppressed him and his research. He had to escape to the United States and so on and so on. So though he published some 100 papers, nobody really followed his line. He just found that a tiny droplet, let it be biological origin or a small ferromagnetic speck of dust, rotates, and they behave as magnetic monopoles. And there are a number of experiments repeated by a Russian couple and published in reputable journals, but no one ever paid attention. And this is, for me, Inca electrodynamics, because Inca people knew about the wheel, but they never used it. So in Europe, we used wheels in chariots and all kind, but the Incas in South America and the Aztecs never used the wheels. So our electrodynamics is an Inca electrodynamics. We don't use rotation at all, though we know that rotation exists. So there is no angular velocity in Maxwell equations. And the book by András Kovács and Celani was very important and revelatory for me on the nature of rotation. What the hell is the nature of spin? What's the nature of rotation in electrodynamics? I encourage everybody to read this book. Very difficult, very, very theoretical. But yet I found there the first traces of reasonable scientific explanation of what is spin. And therefore, there is no hope that we can understand electrodynamics and understand weird phenomena like this. So again, it was published by World Scientific this summer. I had the fortune that I was able to read the manuscript. Very hard, because it requires mathematics, which is not usual, not only tensors, but what's the name? I just forgot. Spinors. So very complicated, but this is the way nature works. We have to obey. No, again, this repeatably. This is the 10 times I'm pushing. Okay, this is another device of ours where we use the surface plasmon polaritons to induce LENR. This is a silent, passive device. It doesn't require loud, dusty plasma as in the previous one, because we got a European research fund for it, but in Hungary it is the usual stuff that inventors are not allowed to apply directly. Only a company is entitled to apply for research grant, and they are always the first to steal all the funding. And in this case, they have stolen 3/4 of the funding, so it was again an absolute shoestring budget. However, in the other 3 cases, they were more agile. They have stolen the funding on the very first day, completely. And this is the usual regular stuff in Hungary. So actually, you see here a cathode and an anode, and this insulating ceramics was covered by tiny droplets of metals, very thin metals. What we used to use a small ceramic droplet, a dust particle, cover it with a very, very thin, and this is important, very thin metal layer, and to resonate it electrically and later with sounds, and use it in hydrogen or deuterium, and we got significant excess heat. Again. Maybe the battery is... Yes, this is the machine in use. Here is when plasma is in the system. We measured with the microphone acoustic oscillations. You can see here the shape of the voltages, and later the whole device was covered with a heat exchanger to measure inlet and outlet energy. It seems that, I don't know which, oh, here is it. I think the battery is dying here. So this is another view when the plasma is on. Oh yeah. This is another close-up right here about the device. It's a high voltage measurement also. It's yet another close-up. You can see isolated spots of plasma here and there. These are the active spots. All right. This is a Russian experiment on rotating dusty plasma. They work independently from us, and they found also transmutations and found excess heat as well. I'm sorry that they couldn't make it here. I shall try to have the next one. I don't know. Which knob? Okay, this is maybe it's too much steps. Yeah. This is the simplest dust fusion device. You can try it at home. This is the way we started. It's a microwave oven. There is a quartz tube with a trumpet-like ending in order to have better acoustic efficiency. And here you have charcoal, and with a piece of graphite, a pencil graphite, with a wavelength of lambda third. And then if you close it, the door, and you switch on the microwave, it starts to ignite, and usually a very long sustained dusty plasma will commence. You can try it at home. It is $20 or so. If you don't do the right order, forgetting the charcoal there, the device, the microwave oven will be ruined. Definitely. Okay, this is in practice, the device you see here. The magnetron is cheap commercial. It is easy to buy. And here we use a spherical microwave resonator, and inside there is a quartz acoustic resonator. So there are several resonating devices must be built together. This is very good for transmutation or let's say hazardous waste disposal, because it will ionize and destroy every chemical bond. No, I tried to have the next slide. It doesn't work. Doesn't work. Anybody has some idea how to make the slides?
I think you've expired your 25 minutes. You can go on for your question time.
Yes. So I was able to finish half of my talk. I had no time to talk about direct electricity production, but in private, maybe we can talk about that. The key lesson for me that textbook physics is not enough for LENR at all, and until the textbook physics are not filled with the gaps, there is no hope to understand different subfields of the LENR. And fortunately, I found in the recent publication on condensed matter physics in the last 5 years revolutionary new stuff, which maybe, and in my opinion, most probably will help us to understand coherent matter, that is the condensed plasmoids. That's it. Thank you.
Okay, we've got time for some questions.
Thanks, George. First, as a plasma researcher, you should know that not everything that glows is thermally hot. Second, in your talk on dust diffusion, obviously I agree it works. I've seen it. When you separated out cavitation and electrolysis, there was a Russian scientist between 1998 and 1997 and 2002 that demonstrated cavitation destruction of matter. It's a very important paper, and I'll review it in my talk. But it was not believed even by the Russian community until the hydrowave technology. And what they did is they introduced electrolysis into the process, and this does something to the process. And that makes it equivalent to what you were doing in the dusty plasma. This is also what was being done by Roshin and Marza in 2003. So if you combine those two technologies, the cavitation and the electrolysis, you end up with a scenario that's very similar to the dust diffusion in terms of the dynamics involved. You have sound, you have the plasmoids in there, and so forth. The last one is on Klimov, which you touched on, with his inflow Tesla coil and charge cluster system. In 2008, because of something I said, he was forced to disclose to me that he used a thermal neutron moderator such as boron, cadmium, indium, gadolinium. And this is in the anode target. And only when he had that thermal neutron moderator element does he see the excess go from up to 2 to up to 10 times. And I forced him to kind of admit that earlier this year. So for those people that are interested in the excess heat, because of the way these charge clusters work, they interact and act like neutral particles, and for some reason thermal neutron moderators are also able to interact with them. There's another aspect which is related to nuclear spin, but I'll talk about that in my talk, and you're right on the money there, so thank you very much.
No, I don't want to comment what Bob told, agreed, and we can continue if there is time for one more question. Yeah?
Several times you spoke about dusty plasma. Which is your exact meaning of dusty? Why mixed plasma? So can you spend some words about?
Dust, in my dictionary, finely ground material in the order of around 1 to 10 micron, or could be of a larger diameter. So actually, if you grind coffee, you drink the coffee and dry it. After drinking the coffee, we tried it. It works. So it's a dust. Coffee dust, I don't know how to say it in English. Any insulating material, if you collect it on the street, the dust, it will work. Any kind of dust must be insulating. So don't use metal dust, metal powder, because then it is one conducting stuff. It will ruin the magnetron. But if it is insulating and you initiate the whole process with a little rod, carbon rod, it will blow up at one end, and the whole process is a runaway process. It will start working. So it's simple to start. The difficulty is with the acoustic resonator and the electromagnetic cavity resonator to design them. That requires years of experience and failures, of course. Jean-Paul has a reactor of mine, an early one.
My question is how you can distinguish between chemical processes that can be involved in your dusty plasma as well. There are some chemical explosions, which are known. From that you want to have for transmutation, nuclear fusion, and so on.
This is a rich variety of all kinds of processes. Of course, some chemical combustion at the very first seconds do occur, because we use usually air, but when we used nitrogen, so no usual combustion is possible, the same effect happened. Or when we used hydrogen, the same effect happened. Hydrogen is very difficult to ignite because it has a very good thermal conductivity, so it's very hard to heat up. But otherwise, nitrogen or inert gases without chemical reaction, the system works. Yes, but it is up to you, the choice. For example, we used The primary goal was actually to make very rare metals like palladium, and we succeeded in artificially making palladium large pieces, and they were not there. So it's a number of brutal transmutation. We found phosphor and sulfur was always there, which were never there before. Carbon, nitrogen, and oxygen, and we synthesized lots of phosphorus, lots of sulfur on the spot, right on the spot immediately, which were never there before. Time over.
I think if there are no more questions, it's time to have our coffee, and we have a half-hour coffee break at the bar. I haven't checked, but your pen is corrupt. Yeah, I managed to get one file from it, which is mass. Is that the one you...
Senti Bill, spostiamo questi due tavoli perché si vede male da giù.
Mi sembra giusto. Sì, spostiamo questo. Perfetto.
I'll send you my slides.
Okay, let me have a look.
Yeah. On the workshop ESCA minutes.
Should have arrived by now. There was a problem repairing this drive. We did unable to repair the drive.
Okay, repair and forget.
No, forget. These are your files, but I can't read them.